These next four examples all have one thing in common. They all have vertical asymptotes. So when we think of a problem with a vertical asymptote, that means when our denominator is equal to 0, we have to check both sides of the asymptote. Either we can check and they're both going to go the same direction, positive or negative infinity, or as we approach the asymptote from both sides, they might go in opposite directions, which means that the overall limit does not exist. So keep that in mind as we are trying these next four problems. So here, this vertical asymptote is at x equals -3. So I need to check both the left and the right limits about x equals -3. So the limit as x approaches -3 from the left, and the limit as x approaches -3 from the right. So I know since it's a vertical asymptote that my answer is going to be infinite. I just need to figure, or it does not exist. I just need to figure out, is it positive infinity or negative infinity, or are they different? So a number to the left of -3 could be -4. So that would make 4 over -4 plus 3, which is positive over a negative, which means that's negative infinity. A number to the right of -3 is -2, so that's 4 over -2 plus 3, which is a positive over a positive, which is positive infinity. So therefore, this limit does not exist. But you have to show this work before you can say this. So in example 2, we have a vertical asymptote at x equals 0. So I need to check the limit as x approaches 0 from the left of the function, and the limit as x approaches 0 from the right of the function. So I know it's going to be infinite, so let's check from the left. I could check -1. 1 over -1 to the fourth is a positive over a positive, so that's positive infinity. A number to the right of 0 is +1. 1 over 1 to the fourth is a positive over a positive, which is positive infinity. So therefore, this overall limit is positive infinity. Moving down to number 3. Well, first, this can cancel, and I get 1 over x plus 1, the limit. So this still has a vertical asymptote at x equals -1. So I need to check the limit as x approaches -1 from the right of f of x, and the limit as x approaches -1 from the left of f of x. So a number I can check to the left, to the right of -1 would be 0, which makes a positive over a positive, which is positive infinity. And then if I check a number to the left of -1, like -2, that's 1 over -2 plus 1, which is a positive over a negative, which is negative infinity. So therefore, this overall limit does not exist. So I showed this to prove that that is true. So last but not least, let's try this one on the left. Vertical asymptote at x equals -1 or +1, but we're only approaching -1. But notice on this one, we're only approaching from the right. So this is nice because I only need to check the right side. So the limit as x approaches -1 from the right of f of x. Something to the right of -1 would be, let's say, -0.5. So that's -0.5 squared over, or not squared here, -0.5 minus 1 squared. So -0.5 is a negative, and -0.5 squared is a small positive 0.25, subtracting 1 would be a negative, so that's positive. So this goes to positive infinity, approaching from the right side. So keep in mind, whenever you have vertical asymptotes, you have to check both the left and right sides in order to determine is it positive infinity, negative infinity, or does not exist.